Okay, this is outline for today's talk, and I will introduce recent progress in foundation models first, and we will talk something about how to play foundation models with MMPreTrain, and then we will discuss how to evaluate foundation models with OpenCompass, and we'll describe the future plan from our team. First, I would like to introduce some recent progress in foundation models. So the first question is, what's foundation models? From the Wikipedia, we know the foundation models, also called the base model, is a large model, is a large machine learning model trained on a vast quantity of data. Typically, we use semi-supervised learning or self-supervised learning so that they can be adopted for a wide range of downstream tasks. Here I list some important milestone works, such as the foundation models in vision, mathematical learning, and computer and NLP. First, we will introduce some progress in the vision foundation models. Actually, the vision foundation models has been widely used in the current multimodality learning. The first is the EVA, which explores the limits of the masked visual recognition learning at scale. This model is a wide vision-centric foundation models to explore the limits of visual recognition at scale. And actually, it's a very nice variety pre-trained to construct the feature from the clip model, and it's become a well-known backbone for the vision-centric and multimodality models recently. And next, I think everyone will know sync anything is a hot work. It's popular work recently. They use a variety of prompts, and it achieved awesome generalization performance. And this model is learned with 11 million images and 1 billion masks. Next work is the DNOV2. It's a self-supervised learning model and trained on enough curated data from the diverse sources. The DNOV2 proposes automatic pipelines to build a dedicated, diverse, and curated image data science. I think this is very important because currently we think lots of works need the data-centric AI, and it trained a VIT with 1 billion parameters and distill it into a series of smaller models that surpass the SOTA algorithms. Another interesting and important work recently is a reversible column network that comes from the MMPreTrain. The first work is the reversible column network, and recently they released the reversible column network V2. Actually, this work aims to build a network to learn the disentangled representations and compare to the multiple copies of the it composes multiple copies of the subnetwork. Each column is the subnetworks, and between the two multi-levels, reversible connections are employed to save the GPU memory for training. And the reversible column V2 keeps the same architecture will pre-training and fine-tuning. We can use auto-encoder architecture, and this work maintain a disentangled low-level representation, and the semantic information and the low-level can be maintained simultaneously and achieve the comparative performance across multiple downstream tasks like the classification, detection, implementation. Next, I would like quickly review the progress in the large language models and the definition of the language modeling. I think we need to discuss this concept firstly because lots of recent works are trained with language modeling. Its main idea is to predict what words comes next. And formally, we can formulate this program as a given sequence of words and compute the probability distribution of the next word. And in our daily application, like the Google search, it's actually the language modeling is behind them. Actually, the language models has developed rapidly in the past few years, but currently we know the popular architecture is decoder only architecture. However, there are three types architecture we should remember. Actually, we think the encoder and the encoder-decoder are also the very important and milestone works. First, I would like to briefly review the BERT. And its representation is correctly labeled BPE, like the word pieces embeddings. And this vector size is 30,000 token. This for the BERT, we calculate can split the learning process into two stages. First, we use self-supervised learning to learn a BERT pre-trained model, and then we use this model to for the different various tasks with mask language modeling and the next sentence prediction objective function. And another important work is T5. Actually, it's explored the encoder-decoder architecture, and the encoder benefits from the bidirectional context, and decoder is used to train the whole model through the language modeling. Next, I think I will know GPT. Actually, it uses language modeling for the pre-training and use the language modeling plus supervised fine-tuning for different downstream tasks. This is GPT-1. Currently, we typically follow the zero shots of the in-context learning without fine-tuning step like the GPT-1. We introduce some different techniques like the instruction GPT, and this split the whole training process into three steps from the pre-training, the alignment with human feedbacks. Actually, this process involved the reinforcement learning to align the human feedback. Actually, the decoder only architecture has become a trend recently. We have seen many excited works like the Intel just described before, and Llama, and some fine-tuning all models with supervised fine-tuning like Wakuna. This is recent progress in language modeling. And next, we will quickly review the progress in the multimodality models. Actually, what's a multimodality model? It will focus on the fusion of two or more model information, such as a language, image, video, or audio. There are some traditional multimodality tasks like the visual question answering, image text retrieval, and neutral language for visual reasoning for real. Some other multimodality tasks like the visual instruments, image caption, and visual grounding are also important multimodality tasks. Actually, recently we are familiar with the visual dialogue, like the GPT-4 just released multimodality function supports the image upload and the audio upload. I think we need to review the history of the recent progress in the multimodality models, and maybe we know how to develop a more efficient and effective multimodality models. Actually, the recent multimodality modeling are quite different from the previous works. In the past few years, we have seen the works like the CLIP has become a very important milestone, and many works follow this pipeline to build a very exciting works. And another trend is multimodality models based on the language models like the GPT. And recently, some works follow the agent-based idea and build some multimodal models which can use additional APIs or additional vision models. Recent LLM-based works like the MinGPT-4, Lava, multi-modality, and Llama Deppin and Otta, they all follow the similar ideas and build multi-modality models based on the large language model. And there are some interesting work recently, like the Internet Composer, Dream LLM, and NextGPT, which suppose we give a text input and we can get the interleaved image and text contents. For the composer, it explores the triple-based idea. For the Dream LLM, it employs different models to produce the image and text interleaved data. Okay, next I will quickly describe how to use the MMPreTrain to play foundation models. Like the Kite introduced, MMPreTrain is an open source pre-trained toolbox based on PyTorch, and it consists of the various algorithms related to multimodality learning and vision backbones and self-supervised learning. It's arranged from the previous open source project MM classification and MM self-suit. For the multimodality algorithm, our framework supports we give an image input and through the vision backbones to extract its image embedding and give the text inputs through text models like the different language models from transformer. We can get the caption output. Currently, we support cutting-edge multimodality algorithm, like the classical multimodality algorithms, like the BLEAP and OFA. Also, we support the recent LM-based multimodality algorithms, like the BLEAP V2 Flamingo, Lava, MinGPT-4, and Otta, and as composer is on the way. Also, MMPreTrain supports the traditional supervised learning, like the image classification or the image retrieval, and we take the image as input and give the image to the different vision bubbles and get outputs. Actually, MMPreTrain has supported a massive quantity of vision backbones, like the CNN backbones and transformer backbones, from the very classic architecture VGG to the recent works like Night or the Efficient Night V2. Also, we support the transformer-based backbone from standard transformer backbones from the VIT to the clip and sign. We also support the lightweight transformers like the mobile VIT, tiny VIT, and other works. Currently, we have supported 50 class algorithms with more than 400 checkpoints. Also, the MMPreTrain supports self-supervised learning, and we can use self-supervised learning to learn some foundation models for different domain and different tasks. Actually, the self-supervised learning aims to develop a pre-test task to the supervision can be generated automatically, and we can leverage the millions of unlabeled images to such a model. Actually, self-supervised has also developed rapidly in the past few years, from the 2015 to this year. We have introduced some milestone works from the handcraft pretest task, like the colorization jigsaw puzzle, rotation prediction, and also the contrastive learning-based idea. And recently, the more masculine image modeling ideas, like the MAE and BEIT. Also,
so I see 23. We are struggling for this issue and thank you for your questions.
let's continue. And MMPreTrain currently supports lots of self-supervised algorithms from the early works, like the relative implication and the clustering based ideas and the cluster. Also, the contrastive learning and milestone works, and recently massive image modeling works. The framework overview of MMPreTrain is illustrated here, and we have the main library, MMPreTrain, and some start scripts and helpers function. Benefit from the universal framework design. the backbones trained and supported in MMPreTrain can be adopted to different MM servers, open source projects like the MS segmentation and MM detection. I mentioned too, you can easily choose your favorite backbones for different tasks. Actually, it's very easy to install and use MMPreTrain from scratch. And we can list all supported models with MMPreTrain with the function list model. And also with provide easy to use API, and you can use the inferencer to inference any images you uploaded. Here I show a illustration of the how to use MMPreTrain for different tasks. And we can use the image classification and list all supported models. Also, benefit from supporting of the multimodality models, we can use the MMPreTrain to conduct some caption tasks, and you can use MMPreTrain to generate annotation for the multimodality training data. Also, you can use MMPreTrain for visual grounding tasks. And VQA. Also, we can use PreTrain for text to image retrieval. And some recent works like the Composer also supports the image retrieval with a similarity. Okay, let's continue. And you can use the MMPreTrain to train image classification model easily. And we can use the cross-library configuration call to use the string transformer trained with MMPreTrain for object detection. And it's a benefit from the unified framework within OpenMMLab. And currently, you can use MMPreTrain to automatically download the checkpoints. Also, we provide various analysis tools for image classification and for background research, like the visualization tools. You can plot the data augmentation process, and you can plot the learning rate curve and the optimization curve before you start the training. It will useful for the debugging. Also, we provide the visualization tool for the class activation map visualization and reconstruction visualization. Also, for the backbone research, we typically need to analyze this backbone from different metrics like the shape bears visualization or the TSN visualization. You can use all these tools in MMPreTrain with easy command. And also, we can conduct the model complexity analysis with MMPreTrain. It will list the parameters and the flops layer by layer. Also, we support the deployment with MMDeploy, and you can easily to build a model with the Onyx format to deploy it on various devices. Also, we provide the comprehensive documentation. You can start to learn the backbone if you are not familiar with this topic. It's MMPreTrain, and we benefit from the unified framework from the OpenMMLab tool, and we support various different downstream tasks. Next, I will quickly to introduce OpenCompass. It's a open source project released recently, and as a part of the large language models toolchain. Actually, OpenCompass is one stop platform for large model evaluation. It aiming to provide a fair, open, and reproducible benchmarks for large language model evaluation and make it easy to assess the quality and the effectiveness of your language models or multimodality models. Currently, we support 80 plus data sets with more than 400,000 evaluation questions. And OpenCompass has a flexible attention function. You can easily to add your evaluation data sets and models, and you can try different inference methods like the zero shot or few shot in context learning. Also the different COT evaluation methods. And we also support the highly efficient evaluation because we're leveraging the distributed technology. Even the model with 100 billion parameters, we can evaluate within a few hours. And also, the OpenCompass is totally open source and reproducible. You can use it to evaluate all open source language models. Currently, we have different layer in the OpenCompass. First of all, the model layer, we support the base model and the chat model, like the language model or the multimodality model. Also, we split the ability support into the generalist and the specialist. For the journalist, we support the knowledge, reasoning, language, understanding, and safety. For the specialist abilities, we support the long context, the agent to use, and the coding. Also, we support the knowledge retrieval-based evaluation. For the evaluation, we support the automatically objective evaluation and model-based subjective evaluation. You can use OpenCompass to evaluate the large language models with GPT or other open source language models. And also you can use this OpenCompass for your evaluation reports, and also we provide the leaderboard for researchers to find the optimal models. Currently, we have such a distributed evaluation pipeline in OpenCompass, and you can evaluate arbitrary models like the Hugging Face models or the API models or your own format models. And we up to now we have supported the 100 data sets covering different abilities. And also we introduce the task partition and parallelization technology to make it efficient. And you can use OpenCompass to get your output like the terminal log or the CSV table. And also you can configure your OpenCompass with a IAM bots, and you can receive the reminder after you have finished the evaluation. Currently, we have provided a leaderboard in the Hugging Face space, and also we have a own homepage. You can easily to find all evaluation results of different models from the GPT to the open source like the Llama, the Baitran and Qianwen, and the InterM and other famous LLMs. Also, we provide the model card with a comprehensive illustration of the model's performance, and you can also use our model comparison function to compare the performance of different large language models. Currently, we introduce meta prompt templates for user to easily use the different prompt templates and try to find the best prompt for your own application or tasks. And with the meta prompt template, you can finish the prompt engineering easily. Also, OpenCompass has provided comparison documentation. We have provided some introduction of the technology used in the LM, like the prompt engineering and like the how to evaluate the coding abilities of the language models. Currently, the OpenCompass has been adopted in many famous companies and universities. Today, we announced OpenCompass and welcome the community to use OpenCompass for your research and production, and welcome to contribute your own large language or multimodality benchmarks into the OpenCompass. And also, we welcome to raise an issue if you have some expected functions that we haven't supported now. Finally, we will introduce some recent research works based on the OpenCompass and the OpenMMLab. And MMPreTrain is a large-scale vision language validation benchmark for evaluating the abilities of the multimodality models. We create evaluation data sets with curated data collection pipeline, and the data sets come from the different data sources. Currently, we split the abilities in three levels. First is the perception and the reasoning, and totally we have 20 plus fine-grained abilities. Also, we open source. We have released open source benchmark for evaluating the LLM's multi-round tracking capabilities. We introduce a very interesting Turing test and assess the conversation generated by two LLM instances. And last week, we released the low bench. It's a benchmark for evaluating legal knowledge of the LLM. And we introduce the three-level abilities from the memorization, understanding to the applying. And we have 51 data sets in total to evaluate the legal knowledge of the LLMs. For the future plan, we will continue to improve the open source software and with the cutting-edge backbones and advanced multimodality algorithms. Also, we will introduce some advanced training techniques like the fast data loading and advanced training techniques like speed or close AI. Also, the OpenCompass also needs the community's contribution. We hope to release and build more advanced LLM benchmarks with community together. And we hope to support diverse evaluation protocols as language models as a new direction. And the evaluation protocols haven't been explored completely. And we also will support more multimodality algorithm benchmarks in OpenCompass. And that's all for the MMPreTrain of OpenCompass. Thanks for listening. And we will continue to the next part.
Yeah, sorry. See. Hi. Thank you for your talk. Just one question about the research moment to show the platform where you automate LLMs, but is there something similar in part?
You mentioned the evaluation of the language models and the similar open source projects. Sorry, I can't hear clearly.
Yeah, more than we have the platform to automate some of the models. Something that's not going to that.
For the computer vision model, the benchmark has been explored thoroughly in the past few years. Actually, we think how to build benchmarks for the foundation vision models or the multimodality benchmarks is very important. We think the new benchmarks should consider the traditional vision abilities and the vision language or more modality information together.